In part C of this problem, we have this new function g defined by g of x is equal to the integral from -1 to x of f of t dt. We want to find the value of g of -1/2 if it exists, or explain why g of -1/2 cannot be determined. Alright, so since we know f of x is the series, we might be tempted to treat this as one of those problems that we need to do a term-by-term integration of f of x. But that's going to be kind of a problem here because we not only want to find g of x, we want to evaluate g when x is -1/2, which means that we need to be able to find the value of an infinite series, or what it sums up to be. And the only way we know that is with a geometric series. So just because we start with f of x being a geometric series doesn't mean that g of x will give us a geometric series when we do a term-by-term integration. So let's take a look at what that would look like. The next thing that should trip us off, in order for this to really work, we should have the integral from 0 to x of f of t dt. That's the proper way to write the term-by-term integration of x. Now, the first term 1 would really be 1 times x plus 1 to the 0 power. So when we take the integral of that, it's going to be x plus 1 to the first over 1. The second term would be x plus 1 to the second over 2. Third term, x plus 1 to the third over 3. And etc. The exponents in the numerator would definitely classify this as a geometric series, but those denominators are not geometric. And because of that, we cannot tell what the sum of that series will be. And so this is a dead end here. Instead, because f of x is geometric and converges on x between -2 and 0, therefore g of -1/2 that would just be equal to the integral from -1 to -1/2. We replace the x with the -1/2, and f of x dx. Well, we know that f of x converges on the interval from 0 to -2 to -1 over x dx from the previous parts of this problem. So as long as we're in that interval from 0 to -2, therefore we know that f of x is just -1 over x. And so we can bring out the negative, and we know that the integral of 1 over x is ln of absolute value of x from -1 to -1/2, and ln of 1/2 minus ln of 1, ln of 1 being 0, negative ln of 1/2 would be ln of 1 minus ln of 2, and so again ln of 1 is 0, and we end up with positive natural log of 2 for our answer there. So because f of x is geometric, it converges on the interval from 0 to -2, therefore we can substitute f of x with negative 1 over x and do a definite integral from negative 1 to negative 1/2, and we get our answer there.